Okay, parents, so I wanted to cover two division strategies that we have learned, especially because the students will need to understand them so that they can determine the correct answers when they see them on district and state assessments like the STAR. So we have already covered the standard algorithm, which is the traditional way to solve division. So they would use their tic-tac-toe over here where they could list out their threes facts, and then they would just go through standard division. So with this first digit being 1, you can't make any groups of 3. So then they would move over to the 1700s and then look over here and see that they can make 5 groups, and then just follow this process all the way through. They can make 9 groups for 27. And then have the 110 left over, bring down the 2 ones, and then that last 12 ones, you can make 4 groups of 3. So the answer ends up being 594. Over here on the right, we have the partial quotients. This is really important because this is going to be where they have to understand the place values. And then this is where they will have to also be able to identify representations. So it's going to follow similar processes to what happened on the left with the standard algorithm, but what they do is they start with these largest values. So if I have 1,782, I'm still looking, but I'm starting here in the thousands place, and I can see that I don't have any number that can give me 3 sets of 1,000. But if I go back to that 17 and I see on the place value or on the threes facts, I do have 15. So if I wanted to remove this 15, I see that this is 1500. I'm going to put the 2 zeros here. So in order for this to be 1500, that means I removed 5 sets of 100. So then this is why this number over here is 594. When they subtract the whole thing, similar to how they did over here, it's going to end up leaving them with 282, which is what's happening over here anyways. You have these zeros here, and then when they subtracted, they still had this 282. We just don't bring in that 2 until way down here. But you're still doing the same processes. So over here with this remaining 282, you look at your facts again, and now you have 27, which more aligns with the 282. So if I had 282 ones, I could take out 270 ones. So I'm going to do the same thing. I'm going to write over here that I could remove 27 tens, which is 270. So over here, if I was using 27, that means I was doing 9, and then I'm adding that 0, 90, because it's in the tens place. Like I said, it was 27 tens. So then when they subtract, they get the remaining 12, and then that's where you look up here and you again do that 12 ones. So if I have 12 ones, then I can remove 4 groups of 3. That's 12, and now there's nothing left. And then again, you have these values here that make up 594. So 500 plus 90 plus 4 in the end equals 594. So these are why they're called partial quotients, is because if I add all of the parts together, then it equals my final quotient. So the answer is 594. The reason this is important here is because what I did with these place values, they're going to see it on a test similar to those processes, but they're going to be in an organizer. So they're still doing the same steps, but it's in this really long picture. But this problem that's presented here in an area model, again, where you're breaking things up based on their values, the actual question is 5,244 divided by 6. So this is why this is my total, and then these are my groups. So my dividend's 5,244, and I'm dividing by 6. So similar to how you saw just now when I did those partial quotients, if I listed out my 6's, you can see that right here what they did was they went the furthest they could to 52 hundredths, which is right here at 48. And again, if that's 48, I have to fill these two spots. I'm going to fill them with zeros. So in order to get 48, I made these groups here. It was 8 groups, but since that 8 is in the hundreds, that was 800. So this is where that 800 comes up here as one of my partial quotients. And then when I do the subtraction like they did here, it's 444 remaining in the hundreds. I push that over to the tens place as they did here, and now I have 440 tens. So then they're doing that same step, or they look here and they look for something closest to 440. It would be 420. So I would get that number here from 42. Notice that this is in the tens. So in order to make 42 tens, I would need 7 groups of that tens. So it's 70. That's what's happening up here. This is where that 70 is coming in. And then once I've removed all those tens, I have 24 ones left. And then that here, if I have 4 groups of 6 ones, then I can remove the 24 ones. So that was that. Oops, sorry. That is the 4 groups. So when I add all of my partial quotients together, I get that final answer. Right here, this would be 874. So that's represented down here in D, that if I took this original total, I divided it into 6 groups, all of my partial quotients, 874, add up to be 874. Now, most students anyway should be able to identify that C is incorrect because I cannot do 6 divided by 5,244 and then get this number. This is not where my divisor belongs. I need to start with the largest number being the dividend, and that's the same thing with B. The trick should be A and D, and that's here is because this is only numbers from a certain step, that 4,800 being found here with the 6 and the 8. So this is only like one step of the entire process. Again, this whole partial quotient aligns to the process that the students do when they do the standard algorithm. So if you're just traditionally dividing this, you're still going to see all those same steps. Where you look for the 52, you're going to see that it's 8 groups. You remove the 48. That leaves you with 4. You bring down the 4 tens. You still have the 44 like you do up here. You look for 44. You can make 7 groups. Remove the 42. You still have 2 tens. Bring down the 4 ones. And then here, you see it's still 4 groups. And then that removes those final ones. So it's all still the same processes. It's just the students do need to understand that they're moving through the place values and that they are removing groups of hundreds, tens, and ones. We have practiced and already learned the standard algorithm. So right now we're just practicing strengthening that. But we are going to have to go back and really practice analyzing and interpreting models and various ways to show and represent division. So if you could reinforce that with your child, that would be super helpful. If you ask them to explain the hundreds, the tens, the ones, or even ask them to go and show an area model. It's just to again reinforce the understanding of the place values and the processes, because many people, adults included, only understand the steps to what's happening in a standard algorithm. They don't really understand the values and the number sense behind what is happening. So just wanted to give you a peek into what division is looking like in our classrooms. I hope this helps. Thank you again for any support that you can offer. I really appreciate your partnership.